Forget those, quiet, stellar nurseries we usually picture. What if the really turbulent heart of our own galaxy, the Milky Way, was actually a hotbed for planet formation?
Hmm.
That's the kind of mind-bending idea coming out of new research, a discovery that might just rewrite how we think worlds get born.
Yeah, absolutely. For such a long time, the standard picture was planets forming out in the calmer, quieter regions.
Right.
We picture these huge protoplanetary disks, massive swirls of gas and dust, hundreds of astronomical units wide. And the idea was tiny dust grains just gently bump into each other, stick, and, well, gradually grow into planets. That whole core accretion model.
Yeah, and we've seen those amazing pictures from ALMA and James Webb, haven't we? Those disks with the gaps and spirals.
Exactly. Beautiful shots showing planets literally carving out their paths.
Almost serene cosmic construction sites. So it's a real shift then to hear researchers are now looking right into the central molecular zone, the CMZ.
That's it. The very core of the galaxy. It's known for, well, everything. Intense radiation, magnetic fields, just general chaos.
Not exactly welcoming for planet building, you'd think. And it's an international team behind this, Peking University, Shanghai, Cologne.
That's right. A big collaboration. They focused on something like 500 dense cores, these potential star-forming clumps, inside 3 huge gas clouds right in the CMZ.
Okay.
And their basic question was, could planet formation even happen here? And, well, what they found is making us rethink quite a bit.
Okay, let's dive into that, because just looking into the galactic center, that sounds incredibly hard. The distance alone, is it something like 17 billion AU?
Something like that, yeah. Just astronomically far. And remember, 1 AU is Earth to Sun distance. So, yeah, huge scales.
And then there's all the dust blocking the view. Things are pretty faint out there, too, presumably. How did they get a clear look?
Exactly. The distance, the thick dust.
Yeah.
It's a massive challenge. But this is where ALMA, the Atacama Large Millimeter Submillimeter Array, really shines. Its capabilities are just phenomenal.
Ah, right. ALMA.
They used its dual band imaging. So observing the same spot in 2 different wavelengths, but crucially with the exact same resolution, the same level of detail.
Okay.
It's an ingenious way to sort of peel back the layers of dust and see much smaller structures down to maybe 1,000 AU, even from so far away.
Wow, that's incredible precision, like spotting, a specific pebble from miles off. So, okay, they pierced through the galactic smog. What did they actually see that got them buzzing?
Well, this is where it gets really interesting. They found that over 70%, 0% of these dense cores looked, well, red in the ALMA data.
Red?
Yeah, red. And not just, a little bit reddish. It was a really significant, unexpected thing. Feng-Wei Xu, one of the researchers, said, we were astonished to see these little red dots scattered across the clouds. He said they reveal the hidden nature of these cores.
Little red dots, catchy, but why red? What makes a star-forming core look red through LMA?
Okay, so there are 2 main ideas floating around, and actually both point towards planet formation potentially happening.
Interesting. Go on.
First one is optically thick disks. So imagine these brand new stars are wrapped in really compact, really dense disks of gas and dust.
Right.
These dense disks can basically act like a filter. Think of really thick fog. Shorter wavelengths of light, like blue, get scattered or absorbed easily. But longer wavelengths, like red light, can push through more easily. So the disk blocks the blue, lets the red escape, and bam, the whole thing looks redder.
Okay, that makes sense. A dense disk, the kind of cosmic red filter. What's the other possibility?
The second idea involves the dust grains themselves. In normal disks, tiny dust motes stick together and grow into pebbles, maybe even boulders.
The building blocks of planets.
Exactly.
Yeah.
So if these cores in the CMZ already have a lot of these larger grown-up dust grains, maybe even getting blown around a bit by winds from the baby star, these bigger grains would dominate the heat signature, the thermal emission.
And larger grains emit more red light.
They emit more strongly at those longer, redder wavelengths that ALMA detects.
So hang on. Either way, you slice it, super dense disks or already grown-up dust grains. It smells like planet formation, doesn't it? Even in this crazy environment.
Precisely. Both explanations strongly hint that the conditions or ingredients for forming planets might be present.
And they found loads of them. You mentioned a number.
They estimated potentially over 300 of these systems in just those 3 clouds they looked at. 300.
Wow. That's a lot more than anyone expected, right? Given how hostile the CMZ is supposed to be.
It really is. It kind of flies in the face of some earlier models. Those models often suggested the intense radiation, the crazy turbulence, the strong magnetic fields. They should just tear these delicate protoplanetary disks apart before they can do much.
Yeah, you'd think it would just be too violent, shredded before they even get going. So this discovery just opens up huge questions then. Like, how are these things surviving?
That's the million-dollar question, isn't it? What allows these potential disks, assuming that's what they are, to hang together in such a rough neighborhood? And it makes you wonder about the process itself. Do these extreme conditions maybe speed things up or slow them down? Maybe the high density helps things clump faster initially.
But then the radiation blasts it all away later.
Perhaps. Or maybe it hinders growth in other ways. We don't know yet. These are the big unknowns this research throws up.
It definitely broadens the picture of where planets can form. We've been so focused, understandably, on places that look kind of like where our own solar system formed, relatively calm.
Exactly. And now we're seeing, pretty compelling hints that maybe planet formation is more resilient, more versatile. It might happen in a much wider range of galactic environments than we thought.
So thinking bigger picture, this could mean there's a huge diversity of planetary systems across the Milky Way, formed under totally different rules.
That's the implication, yeah. It suggests planets might be forming under radically different pressures and conditions all over the galaxy. Maybe, with better telescopes, deeper surveys, we can start mapping out these different zones.
And asking questions like, how different are planets born in the spiral arms compared to the galactic center? Could there be types of planets out there we haven't even imagined?
Precisely. Born from these really extreme galactic nurseries. It's a fascinating prospect.
Okay, so the key takeaway for you listening is this really surprising discovery. Signs of potential planet formation right in the turbulent core of our galaxy. A place previously thought, too extreme.
Absolutely. And those little red dots, seen by LMA, they're the clue. Over 70% of the cores look red, suggesting either those compact, thick disks or lots of large, already grown dust grains.
Both pointing towards planets.
Both pointing towards the possibility, yeah.
Yeah.
Suggesting the building blocks might be way more common in the center than we dared to think.
It really makes you stop and wonder, doesn't it? Given this, how does the sheer variety of places in our galaxy actually shape the kinds of planets that end up forming? What other surprises are hiding out there in those extreme cosmic corners? Seems our story of planet formation just got a whole lot more interesting.